Hi everyone, welcome to the first bonus topic of Harvard Women's Psychology's crash course in R. Today we're going to tackle data cleaning. So if you've never taken any of the previous topics in this course, I would say you're probably okay as long as you have some basic familiarity with R. But if this is the first time you're using R and you're just jumping into data cleaning because that's the biggest thing you're interested in, I would suggest at least going back and doing topic one, because we aren't covering things like how to use the RStudio environment. So we're not going to go through, what all of these buttons mean. We're not going to talk really much about variable types or the dplyr verbs. So I would recommend going through topic one because a lot of what we're going to do today builds off of ideas that were introduced in topic one. But what we will cover, as is listed here and also throughout the script, we're going to talk about basically everything you're going to need to know in order to get your data cleaned. So we're going to talk about removing duplicates, irrelevant columns, irrelevant rows. We're going to talk about fixing existing variables, so renaming columns, cleaning variable levels. We're going to talk about creating new variables, so both manipulating variables, pasting variables together, everything like that. We're going to talk about changing the shape of data. So say your data is in wide format, you need it in long format. How do we do that? Again, don't worry if none of this makes sense now or you're not familiar with these terminologies. We'll get there by the end. And then finally, how to merge data. So if you have two data sets, how do we bring them together in a way that makes sure that we're not losing any information? So with that, let's jump right into it. First, we're going to load the tidyverse. So for those of you who aren't familiar, tidyverse is a collection of packages. So I have the help page pulled up, but basically we're going to be loading in things like dplyr, tidy text, all of those packages. So mostly we're going to be using dplyr. So again, if you're not familiar with dplyr, I suggest going back and doing topic one, because throughout the script, I try and do everything both in base R and also tidyverse. So for example, dplyr is one of the tidyverse packages, and here I've shown you how to do basically the same computation in both dplyr and base R. The reason for doing this is because in some cases, base R is a faster, more elegant solution, and in other cases, I prefer tidyverse. So I want to give some direct comparisons so that you can start understanding in what situations should you be using base R and what situations should you be using dplyr. Of course, both are always working, but there are definitely cases in which one or the other is a more elegant solution. Okay, so today we are going to, and I'm going to first just make sure that my working directory is in the same place as my data, because otherwise, as we learned in the first topic, your data won't load. So we're going to be working with some data from the Met Museum. So I've included the link to the data here. Most of the variables are pretty self-explanatory, but if you really want to do a deep dive, feel free to look through the documentation. So the first thing we typically do when we have our data set, we're first just going to check it out. So you might look at the dimensions. Okay, we have 54 variables and we have almost 40,000 observations. I'll look at the structure. So this gives me a peek at all of the variables along with the class of the variable and some initial information about it. So we can see the different levels, for example, for the first 5 or so observations. We might also want to check out the class of the specific variable. So for example, the repository variable is a character. We might want to look at a table of the variable. So here we can see that we have lots of levels saying that the data is coming from the Metropolitan Museum of Art in New York. And we also have some empty variable NA. So again, this is already an example of where we'd want to do some cleaning, because rather than having this completely blank level, we might want to have an NA, for example. But we also, right now, don't even know really what this level is. So it could be 3 spaces, it could be 1 space, it could be no spaces. So one way to do that is by checking the levels. But if we do that, we'll see that we're getting null, which just means that our class is not a factor. And we already learned that from above. We have a character, but we can basically just coerce it to a factor and check it out like this. And we can see that the level happens to be, in this case, actually, it's just fully blank. So we're going to come back to how to fix NAs later, but this is just an example of as you're going through and just exploring your data, you might already start noting some issues like this that are going to make some of your analysis harder later on. Because we don't really want this to be treated as a level, we want it to be treated as an NA. So just jumping into the first section, removing duplicates, irrelevant columns, and irrelevant rows. So how might we remove duplicates? First thing we need to do is be able to identify the duplicates. So one way of doing this is by looking at the number of distinct rows in your data frame. So we can do this using ndistinct, and we can see that we have 39,527. Already, if you're remembering the dimensions of the data, you'd say that these aren't the same. And again, if we check this, we can see that the dimensions of the metadata, which we use dim, are not the same as the number of distinct rows. So in order to remove them, we'd either use distinct if we wanted to use dplyr, or unique if we wanted to use base R. So we can see both are giving us 39,527. And you might have noticed that in this case, distinct was faster than unique, but they're pretty much the same in terms of, the amount of time it would take you to type it out. So let's go ahead and just grab only unique. So we're removing any duplicates already. And we can go ahead and run the second one, even though it's not going to do anything, but just to show you that we're not getting any errors. So that's just a really easy way to remove duplicates. And the reason you want to remove duplicates is obviously because, if you're running a regression or something, you don't want the same participant to count multiple times if they shouldn't. Okay, so now what about removing irrelevant columns? So if we look at the names, this is going to show us all 54 variables. Another way that we already did earlier is by looking at the structure. So this might be helpful because if you start looking at columns and you say, oh, wow, this column looks like it's just empty. Of course, you'd want to do this by looking at the table too, but it's just good to get a sense, especially if this is your data set, you're going to know really well columns that might need to be deleted or are just completely unnecessary. So for example, let's take a look at this excavation column. You can see that, okay, maybe for some reason, this was just something that you downloaded from Qualtrics and there are a bunch of extra columns and this is one you want to remove. So you can go ahead and remove it by calling this specific column. So remember, it's always bracket, row, comma, column. So this is taking the 44th column, which if we look at the table, we can see that we're getting the same information as we were earlier. So this is just double checking that we knew that excavation was the 44th column. Again, you'd also know this by looking at names. You can say 41st, 42nd, 43rd, 44th. Okay, so we can remove it. Let me just make sure I didn't already do that. We can remove it by just doing null. Now, if we look at the 44th column, we're going to see it's a different column, and we can also see that we now only have 53 variables. So I'll note that I would recommend in general not doing this unless you're going to do it at the very top of your R script, because as you remove columns, as you add columns, your index changes and you don't want to accidentally remove columns that you didn't need to. So totally fine if, for example, the first 3 columns of your data set are, random strings from numbers or totally irrelevant and you want to clean up the data set, but I would recommend doing it in the beginning and being really, really careful. A safer way of doing this is just to actually specify what the variable is. So for example, we can look at this metadata date and you can see that it's basically just NAs. Again, to be really sure, we would call a table, but just for the sake of brevity, let's just say it's all NAs. And we'll go ahead and remove it. Again, now we have 52 variables. So this is all ways to do it in base R. But if we wanted to do this in dplyr, we would use the select verb. So there's some documentation if you want it. You can do that by looking at the question mark and you can read all about it. But basically all you're doing is you have your data set, then you have your pipe and you say select. So you can remove a variable by using the negative sign with the variable. And just so you know, if you wanted to just only keep that variable, you would do the exact same thing, but just do not include the negative sign. What we're doing here is we're just removing this artist alpha sort variable. So if we go ahead and do this, you can see now we're down to 51 variables. And again, if we look at names, if we were to look through this, we would see that there's no artist alpha sort in the data set. Another thing we can do is we can actually specify that we want to remove anything that starts with some string. So for example, we might not care about anything that starts with the word object. So for example, we've got this object Wikidata URL, we have object number, object ID, let's say all of these are irrelevant, then we would go ahead and use this. But let's also say that, okay, we actually care about two of them. So we care about object number and object ID. So what we're doing here is we're removing these two, but we're saying that these two are exceptions. All right. So we can run this. And now if we just want to check our work, we can use basically the same thing, except we're saying select only those that start with, and we're going to look at our data. And basically what we just want to double check is that these two columns that we told R to save are in fact still in the data set. And if you want to explore some of these other arguments, just know that you can also use select with things like ends with or contains, and I've included a link of all of these arguments here. Okay, so we've talked about removing duplicates and irrelevant columns, but what about irrelevant rows? So we can do something very similar as we did above. So this time, rather than doing column and then null, we can actually just use the negative sign here. So again, it's a row, comma, column. So if we want to remove the very first row, we can just do this. We'll just double check. So right now we have it in 27. Now we can see that we removed the first observation. Another way to do this is by using dplyr is by using the filter verb. So again, filter means that we're literally filtering the data set for rows that match a specific argument or condition. So here, what we're saying is if the row number is equal to 1, then we're going to remove it. So now we can see we have 39,525 observations. So just a reminder that the exclamation point here means not. So in this case, the row number is not 1, but other helpful cases of this are saying it's not an NA, for example, which just means, like I said, not an NA. You can also do this if you want to say something like my variable is not equal to 9. These are other cases of where you might see this exclamation point or it might be useful to you. So if you want to remove multiple rows by their index position, basically you can just concatenate the numbers. And rather than having the negative sign before the number, you're going to put it before the concatenate. So this is telling you for everything inside here, we're going to remove. So let's just do a quick head so you can actually see. We've removed the first one. So we now no longer have object 3. And then we've also removed 5 through 8. So we're removing 7 and 8. So we should just have 4, 5, 6, and then other numbers. So we have 4, 5, 6, 11, 12, 13. Great. Again, if you wanted to do this in dplyr, you would do something very similar as above, except rather than having this equal to, you would use this in, which is just saying, I want to filter anything that's in, and then your concatenated vector of items. So this is by index position. If you want to do something similar, except by condition, what you can do is, again, you have your data frame and then your row specification. So what we're doing here is we're filtering any rows where the department is not equal to medieval art. We've removed quite a few observations. You can do a very similar thing in dplyr by saying my department is not equal to medieval art. So really the only difference here is that we're piping and using filter rather than doing it in one line of code. So again, you might see that base R in this situation might be just as good, but once you start including multiple different conditions, you might notice that dplyr is a little bit easier to read. At least that's the case for me. So for example, when we use multiple conditions, we can say, I want something that is either not medieval art, or, so that's what this character is, or the classification is paintings, swords, or sculptures. So just to make this super clear, let's look at the table. And you can see that there are tons of different types of classifications. But once we do this and we're saying I want one or the other, so it could be a painting, but medieval art, for example, you can now see that we still have lots of different types of classifications because we're allowing either to be true. However, when we say and, it means that it can't be medieval art because we're saying the department can't be medieval art and it has to be one of these three. So once we run this line of code, you can see that we just have these three classifications. Okay, and we're not going to have any medieval art included. We can do this, you can just double check by saying filter department equals medieval art. So we're going to check if there are any. And we can see that there are no rows. So this is working properly. Again, you would do something super similar in dplyr. Actually, we'll just write this here. And just remember that when you're using dplyr, you don't need to write the data frame $. You can go ahead and just write the column name because it already knows where the data are coming from because you have it piped in. The other thing you might notice that I'm doing is I don't need to add this and sign because a comma is going to basically act as an and. So I can just go ahead and look at the dimensions. And you can see it's exactly the same as what we have. Okay, so I'm just going to include this here in case anyone wants it. Okay, so obviously we've been using this in operator, but if you ever want to use something that says not in, so let's say you want all classifications except for anything that is painting, swords, or sculpture, you can do that by creating your own not in operation like this. And in order to actually use it, you would say something like this. Use the exact same format as before, except now you've replaced this in with not in. And you can see that now we have lost our sculptures. I haven't actually assigned it, so it's not going to be lost from the main data set, but it's lost here. And just a quick note that even though when we're creating the operation, we have it in quotes, if you try and run it in quotes here, you're going to get an error because it's now interpreting it as a string. That's why it's turned green. Unlike how we have the pipes and how we have our in operators, those are both gray. So just keep an eye out for this. Don't just go ahead and copy the entire thing. Make sure that it's gray so it knows that it's actually doing an operation rather than just a string. If you want to do this in dplyr, you can go ahead and still use the same characters to mean or. So in this case, we're saying the exact same thing as above. It can be either not medieval art or painting, swords, or sculptures, or we can say they both need to be true, and we'll do this by either using an and or by using a comma like we did below, or like we did above. Okay, so we've done the first section, and I know I'm going really, really fast, but there's a lot of material to get through. The next thing we want to do is fix existing variables. So one thing we might do is try and rename columns. So for example, let's say we have this column called is.timeline.work. If you are trying to go through and every single time you're trying to call this, you have to write is timeline work. That's a pretty long variable name. So you might want to go ahead and replace it with something shorter like highlight. So you can do this by using the index. So again, 2 is saying the second column. And you can just check that by looking at your names. And we can replace it with highlight. So now if you were to look at the names again, you can see that the variable is now called highlight. You can also do this rather than by using your index. You can do this by specifying the name of the column. So I know that this looks a little bit more intense. So this is, again, a situation where dplyr might be a little better. But basically what we're doing here is we're looking at the names of the data frame. Then we're saying if the names is equal to rights and reproduction, we're going to rename it to be called rights. We can go ahead and do this and now check that we have a variable called rights, which we do. Great. Another way you can do this is by actually just creating a new variable and then deleting the first one. So for example, let's say we have this variable called artist.display.bio, again, pretty long, and you want to replace it with something called bio. One thing you can do is actually just say, I want to have this new variable called bio, and I want to fill it with artist.display.bio. So we do this, we can see, we'll try the tail, that what we have for bio is going to be the same as artist display bio. So now we have two columns that are just repeating each other. We don't really want that. So we'll just go ahead and delete this column, which we can do by specifying it as null. Now we have something called bio, but we no longer have something that says artist.display.bio. If you wanted to do this in dplyr, what you would do is you'd use this to rename function. And here what you're doing is we're saying, okay, we have this variable called artist display name, and we want to rename it artist. So just notice again that the format is new name. So the new column name is artist and the old name is artist.display.name. So old name equals new name is always the format. Okay, let's say you want to rename multiple columns at once. How do we do this? So I'm just going to create a quick test data frame. And I'm going to go ahead and rename all of the columns. So right now we have is highlight, highlight, etc. We're going to rename all 5 of them at once. Name 1, name 2, etc. Now we have new name. So basically what we're doing is it's just mapping name 1 onto the first column name 2 onto the second column name, etc. So obviously you wouldn't want nonsensical column names like this, but this is how you would go about doing it. Okay, in dplyr, you would do this very similarly as above, except now what you're going to do is separate each new column name by a comma. So rather than concatenating it like you have here, you're just going to say, okay, I want to rename the column called name 1 with new name 1. I want to rename the column name 2 with new name 2. So the reason that this could be nice is because you don't have to actually manually rename every single column, which is nice. So for example, if you tried to do this, let's give it something else. If you tried to just do it without renaming all of them, you all of a sudden lose the names of the other ones. So this is obviously not ideal because you don't want columns that are not named. So this is another situation where it might actually be better to use dplyr because you don't have to rename every single column, but you can do multiple at once and fairly easily. So let me just rerun this code, and you can see that now we have renamed just these 2 columns, and we still have names for all of the other ones. Okay, so cleaning and fixing levels of variables. For characters and factors, typically in order to check the levels, you would either call a table. So in this case, we're just checking out this classification variable, or you'd call the levels if you're worried about white space or other weird characters getting in. Again, if you get this kind of error when you're trying to call a level, that means that your variable is not a factor. And so you can just wrap this as factor around your data, and now you can see your factors. So what I was talking about with white spaces, and the reason this is important is because here you can see the exact string of your variable inside these quotes. If, for example, there was a random hanging white space after painting or before it, if you try to use any of these filtering, either here, so I guess in this case, it would be a variable level. If you tried to use paintings, but it was really paintings, you're going to get an error. So the reason this levels can be handy is because it can tell you if there are some of these random white spaces at other places in the variable name. Otherwise, this might cause issues later on, and you won't have any idea without if you were just looking at the table. But just know that we haven't actually changed the class of the variable by writing as factor because we haven't assigned it. So if we just check out the class, we can see that it's still a character. And when I say assigning, I just mean that we're using the caret and we're pushing something into that old data set. Okay, for numeric variables, you can check out the levels of the variables, both by looking at the tables and levels like we did above, but also by calling a summary. So the reason summary can be helpful is because you can see things like the minimum, the maximum, the median, how many NAs. The min and max are also super helpful because sometimes the data might be coded as 99999 to be an NA or some negative number. And if that were the case here, you know that 999 would not be a correct year, and that may tell you that, okay, later on I need to fix that. I need to make that an NA rather than a string of nines. Okay, and again, as you can see here, I've wrapped this as numeric because by default, without doing anything, the class of this variable is a character. And if you try and run summary on a character vector, you're not going to get the same information you got when it was numeric because it doesn't know how to calculate the minimum of a string of letters, or in this case, numbers, but R doesn't know that this is a number unless you tell it. Okay, so how do we change the class of variables? Well, I'm first going to just go ahead and create a new variable that adds 0.2 to every year. The reason I'm doing this is because I want to demonstrate the difference between an integer and a number. So if we do this, just go ahead and show you. You can see that now we've got lots of years and 0.2. But again, the class of this variable is a numeric variable because we've called as integer here. Okay, but if we were to turn it into an integer, you'll now see that we have lost those decimal points. And so R is going to round to the nearest whole number because it's now an integer. But if we were to turn it into as numeric, you would see that we still hung on to those decimals. So depending on your interest, you might want to keep things numeric, or you might be interested in integers, but either way, this is how you transform them. If you want to turn something into a character, you use this as.character. And if you want to turn something into a factor, you use as.factor. So as dot and then whatever type of variable. Note that if your variable is already a factor, but it should be numeric, So for example, you have your year data and that variable is a factor. You need to actually turn it into a character before you turn it into a numeric value. So I'll tell you why in a second. So first, let's go ahead and turn this year variable into a factor. You can see that it looks totally normal, right? If you didn't know the class of your variable, if you weren't checking, you would see all of these levels and you wouldn't think anything of it. However, if you were to try and turn this into numeric, you'd notice that all of a sudden you lose the semantic content of your numbers. So now 1891 has turned into the year 4 because your levels are 1881, 1885, 1889, and 1891. So you might have already picked up on this, but basically what it's doing is it's saying, okay, you told me I have this factor, and it's just numbering them. So your first factor is 1881. So that is now 1. Your second factor level is 1885. That's now 2, and so on. That's why you have a bunch of 1891s and you have a bunch of 4s when you turn it directly into a numeric variable. So in some cases, this might be what you're trying to do. So if you have variables that correspond to maybe age ranges, maybe you actually want to change them into age range 1, 2, 3, etc. But for something like a year, most likely you're going to want to keep it as numeric. And so the way you do this is by turning into a character first. And by turning it into a character, you're telling it to basically treat these individual strings as something that are unique and important, rather than treating the entire thing as one factor, one unit together. So the difference, again, is this is a meaningful unit in a character. This is the meaningful unit in a factor. So now when we wrap character before we wrap numeric, we can see that we have the data as expected now. Okay, again, promised you I would always show you things in tidyverse too. If you want to do something similar in tidyverse, all you're going to do is wrap these as dot functions into your mutate. Again, mutate is the dplyr verb that creates a new variable. In this case, you're actually just going to be writing over your variable called period. But you can also use mutate to create new variables, and we'll talk about that later. Okay. So if we go ahead and do this, now I can check the class of my variable called period and see that it is a factor. Great. All right, something that's already come up is we had some weird values for NAs. So for example, you can see that we have over 2,000 rows that actually are just totally blank for this period variable. So we've got tons of actual period data, but for this one, we don't have any. The problem is, and I've already run this line of code, but when you say is NA, R doesn't recognize any of these 2,000 rows as being NAs because it's treating this level as its own level. So this is important because if you were to run a regression or something, R is going to treat this as a level, even though there's no data there. And that's not going to be correct in our model. So again, if you wanted to see, okay, is it just a blank space? Is it several blank spaces? You could look at levels, and you can see that in this case, it's actually just a blank level. And so what we're going to do is we're going to use our if-else statements. So for those of you not familiar, we have our condition. So in this case, met period equals blank space. If that's the case, it's going to be an NA. And if it's not, we're going to turn it into whatever was already in this period variable. I'm just making sure that it's staying a character rather than turning into a factor or something, because maybe eventually we are going to want to remove the word period from these levels so that it keeps it more concise. But for now, we're just going to leave it. And once we do that, we can see that it's correctly recognizing that 2,000, which is actually the majority in this case, are NAs. Okay, so say you recognize that your entire data set is like this. What I mean by that is every single time there should be an NA, it's actually just this blank. What you can do then is you can say, I'm going to filter my entire data for those empty strings, and I'm going to replace those with NAs. So we can go ahead and do that. And now you can see that we're getting these lovely NAs showing up rather than just blanks. Another way you can do this is you can use this replace, which says, okay, give me my data set, give me my condition. So metadata equals blank, and let's replace it with NA. So you could do that. And just so you know, you could obviously replace NA with a different value. So if you wanted to do, like I have here, not available, you can do that too. But typically it's good to use NAs just so you can spot them in these NA functions and things like that. If you want to replace NA with a different value, like I just said, what you can do is you can use this replace NA and say, okay, for this variable metadata period, where let's replace any NAs with not available. Now you can see that it did that properly. Like I said, you can also do this in base R by just replacing this NA with not available or whatever you want to replace it with. Let's say that you don't want to replace it for every single value in your data set. You just want to replace the NAs with another value for specific types of columns. So say you only want to replace this, for example, for numeric columns, you can do something called select if. So basically selects columns that fit a certain condition. For this case is numeric. So we're selecting only numeric columns. What we can do is we can use this mutate if. So mutate if is numeric. So it's very similar. I just ran this line to show you what columns, for example, would come up. So it should be only impacting these three columns. I'm going to mutate these columns, so change them. And I'm going to replace NA, exactly what we did earlier. And for all columns, that's what this dot means. I'm going to replace the NAs with -999. So if we run this, now we can see that our first row is replaced with -999. Again, I think it's better to use NAs in most cases, but this is just demonstrating how you would do it if there is a specific certain situation where you need to. Okay, removing white space, again, this is something that's come up before. So we can see, for example, in this artist suffix variable, we have lots of random white space that's just going to make our lives difficult. So in base R, you can remove white space by using this trim white space. All you have to do is include the variable where you want to trim. So we can do this. If we look at levels again, you now see that we don't have any hanging white space. You can do this in teddiers by using string_trim. We can also just grab a portion of each level. So say we have this year variable and we just want to grab the first 4 characters. What you can do is you can use this substring and tell it, okay, for this specific variable, I want to take the first character all the way to the 4th character. So now we can see that we don't have the 0.2 that we previously did. Another thing you can do is if you just want to grab a portion of a level, but maybe it's not always in the same place. So rather than trying to grab a portion of the variable based on a specific placement, you want to grab based on a pattern. You can do this by using string extract or string extract all. For those of you who did the intro to text analysis, you know that the difference between these are string extract is just grabbing the first instance for a given row. And so if we run this, we'll get 3, 3, 7, 9, exactly what we wanted. So in some cases, maybe you want to use this. Probably in most cases, you're going to grab everything, but I just wanted to show you some variation. Another thing you can do is you can actually remove specific portions of a variable. So say we have this link resource link, and what you'll notice is that pretty much everything until this last set of numbers is the same. And so that's not going to be particularly useful for us if we just want to, have this shortcut at the end. So we can do this, that is, we can remove this initial portion by using another regular expression. So all of the regular expressions are here. Basically what this is doing is it's going to remove everything after this search slash. So everything is what this dot means after this search slash. So when we do this, now we just have this unique portion of the link. Let's say you actually want to add a string to a level of a variable. So say we have this object ID and you want there to be no confusion about what this is. And so you add this underscore ID to the variable. You can do that by just pasting your original object ID and the ID together. And this sep is whatever that separator is. So right now, we've made the separator an underscore. You can make it anything you want. Okay. If you want to change the category labels, you can do this first by checking out what the categories are and their order. This order is super, super important when you're using this first way of doing it, which is just calling it from a factor and re-leveling them. So you can first call it table, or you can call the levels. Again, notice that these two are in the exact same order. So this is how R is internally ordering this variable. And if you wanted to, shorten the individual levels, maybe this makes things easier later on, you can do this by calling factor, telling it which variable you want to relevel, and then saying, okay, the new labels are, and then you concatenate your list of new labels. So the reason the order is so important is because if you screwed up the order, then all of a sudden you might have 900 or 691 sculptures, even when it should be paintings. So let me show you, for example, if we had done it in the wrong order, then all of a sudden your variable levels are messed up. So just make sure that you're always calling a table before and after so you can prevent errors like this from happening. Another way to do this in base R is super similar to what we did earlier with renaming columns. So you can actually just take the levels and rename them by hand, just like this. Okay, if you wanted to do this in tidyverse, you can use this recode factor. So what we're going to do is we're going to tell it, okay, for this classification variable, again, let's always call our table. And we can see that we have 3 different levels: painting, sculpture, swords. So we're going to say, okay, I want to take this painting and rename it paint, sculpture, rename it sculpt, swords, rename it sword. Okay, and in this case, rather than being new equals old, it's old equals new. So just a reminder. When we do that, you can now see that we have the exact same thing, but we just have shorter names. Okay, so that's renaming. If you want to reorder the categories, so say you want sculpture to be first, swords to be second, painting to be third. This is going to be helpful if you are, fitting a model and you want something to be the reference category, or if you are going to be recoding your variables, say you wanted to do some sort of effects coding. This can be helpful because if you wanted to do reverse Helmert coding, the order of the variables matters because you're going to be comparing each level to the level before, for example. So it looks very similar with this factor, except rather than having labels, we have levels. So the difference here is now we're saying we're using the levels that already exist, so painting, sculpture, swords, and we're using those names verbatim to reorder the levels. Okay, you can do this, and now you can see that rather than having painting, sculpture, swords, we have sculpture, swords, paintings. So let's say you have a variable with like 15 levels and you don't care about the order of all of them, but you just want to make sure that one of them is the reference category for your model. You can do this without going through and changing all of them by using this re-level function. You just tell it, okay, here's my variable, and then you tell it ref equals, and you set your reference category. So if we do this, you can see now in both cases, sword is our reference category. All right, say you want to add a level to a category. You can do this by using this factor expand function. You tell it, okay, here is my variable, and I want to add this new level called new. Now, all of a sudden, we have 4 levels, and we have this new level. Again, sorry for going super quickly, but there's a lot to cover. If you want to combine categories, for example, so in general, I would say pretty good rule of thumb to create a new variable because you don't want to lose this data or forget that you combined 2 categories. So I typically prefer creating a new variable so you're not losing any of that information. But if you do choose to actually combine 2 categories or 2 levels, you can do this a couple different ways. One way, that's space R, is just using an if-else statement. So for example, let's say if classification is paint, then you want the variable to be paint. If it's anything else, you want it to be other. So we can go ahead and do that. We can see, okay, we now have our still 691 paintings. So technically we use this classification too, which is paint, and everything else is specified as other. If you wanted to do this with tidyverse, you can use recode, pretty similar. You have this classification variable. And now what you're doing is you're saying, okay, I want to keep paint as paint, but I want to make sword other. I want to make sculpture other. Go ahead and do this, and you can see, okay, great. These are 2 separate variables, but they're doing the exact same thing. So it's really up to you, whichever you think is more useful. Okay, section 3, creating new variables. One thing you might want to do is split a single variable into multiple variables. So I'm actually just going to go ahead and create a fake variable just for demonstration's sake. But say we have this variable that's dates, and we have something that's pretty typical date format if you're from the US. But you want to actually create 3 new columns called month, day, and year. What you're going to do is you're going to say, we're going to separate this date column. And what we're going to use to separate it is this character. So notice that I've wrapped it both in a bracket and a parenthesis. This is just because it needs to know that this is, we're treating this as a character. So sometimes this happens. If this were a letter, we wouldn't have to wrap it, but because it's sort of a special character, we have to wrap it to tell R, yes, treat this as the separator. Okay, so if we do this, we're now going to have 3 columns that were called month, day, and year. So this is you specifying the column names, and they're using the separator. Note that we now no longer have this date variable. So it's actually removing this variable and splitting it into 3. So if you do still want to keep this date variable, I recommend doing something where you might like create an old variable. So we've now deleted it, but you could do something like this to make sure that you're keeping the variable, but otherwise separate by default is going to remove that original variable. If you want to create 2 variables, let's say, for example, you have this information about artist end date, artist begin date, and you want to calculate how much time it took them to create a piece. You can just subtract the 2 numbers, so subtracting the end date by the beginning date, and calculate this production time variable. So let's say you did this. Don't worry about this error message because it's just saying that some were NAs. So those aren't obviously going to have a specific number, but you can see that we've got a whole range of time. So I can't vouch for the accuracy of any of this. In fact, I would say that most of these numbers seem like they would not be correct production time. But just to give you a sense of how you would do something like this. And again, if you actually look at the individual variables, you can see that some of them don't make a ton of sense. So -356 could actually mean NA, might be something where you would look into the code book and see if something was weird. Another thing you can do is you can paste multiple variables together to create a new variable. So say you wanted to show a range of the production dates rather than creating this difference variable, you could actually paste the two together. So you have your first variable, I'm keeping it as numeric, but I guess technically you don't have to. I'm trying to prevent the NAs from showing up. And I'm going to separate them with this dash. Now you can see, again, we're going to have a couple cases where they don't seem to make much sense. They probably should have been NAs, and you need to fix that later. But we can see that we have some ranges that make sense, and we now have this new variable. If you want to create more simplified variables, you can use if else. Again, lots of these ideas are sort of coming up in multiple places, but just to kind of keep everything straight so that if you're searching for things, you've got a whole list of options. You can create a simplified variable by using if else. So for example, let's say you have this pretty unwieldy credit line variable, which you can see how long it takes even just to load the different kinds. But I spent some time looking at this variable, and one thing I noticed is that a fair amount of them say that they're listed as a gift. And so you can use grepl, which is basically saying, okay, we're searching for anything that includes the word gift. And if it does, so this is again the condition of the if else, it's just a bit longer because we're wrapping it within a grepl. If it includes the word gift, we're going to say yes. If it doesn't, we're going to say no. So now we have this new variable that tells us that about 1,700 of these rows were actually given as a gift. Another way to create a simplified variable is using if else, but with multiple if else's, so nested if else. So what we're doing here is we're saying if city is in Baltimore or New York, we're going to call it US. If the city is in one of these levels, we're going to call it Italy. If it's anything else, we're going to call it other. So this is just how you can create more than two. If you wanted to continue, basically what you do is you would replace other with another if else statement and keep nesting. If we run this line of code, you'll see that we have three levels, Italy, other, US, which is exactly because we had, actually, I'll even just make it a little clearer. So these are the three variable levels that we're creating, and these are the two conditions. So you're always going to have one fewer condition than number of levels because we always have the condition and then what it is, and then if it's not the case, something else. So here we have if this, then this, if this, then this, and then anything else is this other condition. Okay. One of my most favorite functions in R is case when. So it's another way to make these simplified variables. So here what we're doing is we're using mutate, which can create a variable. We're creating this city simple variable, which basically says if city is in Baltimore or New York, we're going to put it in a level called the United States. If city is in one of these, we're going to put it in a level called Italy. And if it's anything else, so that's what this true is, we're going to call it other. So notice that a big difference between this is that rather than having this comma, we're using this little tilde, and that's saying this is the condition and this is the new level. So what I like about this is I feel like it's pretty easy to read because each condition can be put in its own row versus if else statements can get a little bit messy, and sometimes we can get lost with parentheses. So again, totally up to you, but this is, I think, case one can be really, really helpful, especially when you're dealing with lots and lots of conditions. One thing we'll note is that case one is reading everything in order. So it's going to first look for Baltimore and New York, and then it's going to look for all of these. So the reason I'm noting this is because if it's the case that you have, for some reason, something that's Baltimore is the US and also Italy. So maybe a better example of this is if you had something where the level was actually the name of a town in both US and Italy, it's going to categorize it as first being in this. So just be careful and remember that it is doing things in order. And so if it is the case where things can be in multiple categories, just be careful because of the way it works. And I should note that if else is also doing the same thing. So be careful of how you're ordering things, depending on whether you're using grepl or, a less than, for example. If you do less than 4, but then later say equals to 0, everything is going to be coded as that first one because of the way that if else works. Okay, almost done. We've got a quick one here, changing the shape of your data. So if you're not familiar with the nomenclature wide format and long format, wide format means that one row is equal to one subject. So for a given column in a given row, that's referring to a single instance. So every single column is still for that same subject. Long format, multiple rows can refer to the same subject, but in a different condition or at a different time point. So one row might be person number 1 on the first day of testing. The second row might be person 1 on the second day of testing, et cetera, et cetera. And in that case, all of the rows might be a value for the same question on a questionnaire, but on different days, for example. So let's just create a fake data set where we can just look at this. So like I said, this would be an example of long data where we have this value. So say it's just a question on a questionnaire, and we have the subject ID. So we have a person who is in both condition A and condition B. So this is within conditions. And we have this for all 5 of our subjects. So if we wanted to convert this to wide format and make each subject just have one row, we can use a couple different things. We can use reshape, which is a base R function. We can use spread, which is a tidyverse, and we can also use pivot wider, which is also tidyverse. It's just newer. So if we use reshape, basically you tell it the data frame, you tell it the ID variable. So basically the ID variable is a variable that tells it which observations are connected to each other. So if we used condition, that's not going to make a ton of sense because it's going to say there are only 2 unique IDs, but in fact, we have 5 unique people. So just be super careful about making sure that you're choosing the right ID variable. Your time variable is the variable that tells you how those 2 rows are different. So if you were to use subject ID, that's not going to be right because that's telling you different people. The condition in this case is the one that's telling you, okay, row 1 and 2 are different, not because they have different values. That's sort of a consequence of them being at different times, but because they have, one was in condition A and one was condition B. And the direction here is wide because we're trying to transform it into wide format. So if we did that, you can now see that we have something where we have our subject variable for all 5 subjects. We have our value A, which is just taking this A from the condition variable. We have value B, which is just taking this value plus B. We can do something super similar with spread, where we have our data frame. Key is how we're separating the different rows. And the value are the values that should go into this, that should be sort of connected to the conditions or the keys. Okay, let me just show you what it looks like because that can be a little bit confusing. But now what you can see is we have the exact same thing. The only thing that's different is the column names. So when we used reshape, it took basically just pasted the original column name with the level, versus here we're just keeping just the level name as the column. So it's doing the same thing, but we're getting slightly different columns. Okay. We can also use pivot wider. I'm just gonna comment that out. I just included this here just to show you and remind you that whenever you're piping things in, you can always add different dplyr verbs. What we're doing here is we have our ID columns, which is very similar to what the ID var argument was for reshape. Then we're taking names from, which is just saying we're going to use the names from this condition variable. If we do that, you can see again, we now have the exact same thing as our data frame 2, but we've just used a slightly different function. sometimes Tidyverse does this where they're constantly updating. And so if you were to look at the documentation for spread, it's going to say something like superseded by pivot wider. So it's still working for now, but it's probably good to start using pivot wider just because eventually this function might not work. Okay, so we've talked about how to convert something from wide to, or from long to wide, but how do we convert from wide, where every row is an individual, to long? So we do something super, super similar, except we're doing the opposite. So we can use reshape. So it's the exact same name, and that's why we had this direction argument. But now we're telling it, okay, we have this data frame. My ID variable is the same thing, my subject. But now I'm telling it, I want to take these two variables, which originally corresponded to the value column, and I'm going to basically put them together. If we do this, you can now see that I've got my original subject, my time, and my value. So note that this is not, it's not going to remember that this column was originally named condition, for example. So you might have to do some renaming of columns if you don't like what it does by default, but this is how you reshape from wide to long. If we wanted to do this with Tidyverse, rather than using spread, which is literally spreading out the values into different columns, we're going to use gather, which is gathering them and sort of putting them together. What we're doing here is we're taking our data frame, we're telling it which columns to put into a single new column. So remember that in wide data 2, A and B were their own columns. And now we're going to paste them into one column, but we're protecting this subject ID because we don't want all of a sudden there to be levels of this condition variable or the value variable that are 1, 2, 3, 4, 5. So if we do this, you can see that we have something that looks pretty similar to our original one, except that, again, the names are different. So we have our subject ID, our condition, A or B, and our values. If you want to do this in the newer way, rather than using pivot wider like we did earlier, you can use pivot longer, which is just all you have to tell it is the columns you want to convert into long form. If we do this, you can check it out and see that it's the same thing except with different columns. So all of these doing something very, very similar. The main difference is a couple of the arguments and what the final data frame looks like. All right, very last section. We are doing it. We are so close. So the final section, we're going to talk about merging data. So I don't want to introduce a full new data set just for the purposes of this one section. So what I'm going to do is I'm take specific rows, specific columns from the metadata just to create two different data sets so we can just do a quick practice about how to put data sets together in different ways. So I'm going to take the first 1,000 rows into metadata 1. Then I'm going to put the remaining rows and 5 overlap. I'll talk about why that's important later into a second data set. And I'm going to add a few rows to each of these new data sets. So I'm now going to add a couple where I'm just calling every single column Cambridge. Don't worry about it. I just want to create new rows so that there's some variation. And I'm going to do the same thing with metadata 2, except I'm going to say London. Okay. Now I'm going to mess around with columns. So I was just messing around with the rows, but now I'm going to mess around with columns. So for metadata 3, I'm going to grab the first 20 columns, and then I'm going to put the remaining columns in data frame 4. Again, then I'm going to create a new column for data frame 3 called famous. And for data frame 4, I'm going to call one called stolen, which is for, quote, stolen paintings. I'm just making this up for the purposes of this explanation. So if data frames, share all the same columns, you can simply use rbind to bind them together. So for example, metadata 1 and 2, I only played around with the rows. So you can use rbind to put them together. Now you can see that our dim, sorry, I went past it too quickly. was 2800, which if you look at our metadata 1, so metadata 1 plus we have the same amount in both, so that worked properly. We can also look at the actual data too if we want. If our data frames share all the same rows, you can simply use cbind. So it's binding columns versus binding the rows. So in metadata 3 and 4, I only messed around with the columns. So all the rows are exactly the same, so we can use cbind. So those are situations where it's relatively straightforward because they likely came from the same data set because either the rows or columns are exactly the same. However, there are many cases in which this is not going to be true, and you have either a mix of similar and different rows or a mix of similar and different columns. And so if this is the case, you can use merges and joins. So what they're going to do is they're going to join based on shared columns and shared values. So for example, what merge is doing is it's taking these two data frames and it's looking at object ID, and it's basically going to match rows that share the same object ID. So it's really important that what you're choosing as by is really something that's a unique identifier, because otherwise if you use year or something that repeats across values, R is not going to know how to put the two together because there are lots of repeated values. So here we are going to join the two data sets. And this is not going to work because what we see is we only have two observations and we have 123 variables. So what's going on? The first thing that's going on is we have multiple columns that have the same name, but we only told it to look at shared values for object ID. So if they share multiple columns, we need to either use this names argument, which is allowing it to have basically every single name shared. If we do this, we still have 6 observations. So what we're going to do is we're going to make sure we include this all equals true, which is basically retaining all columns that don't appear in both data frames. So as a reminder, you can always check out the help files if you're getting confused. But here we do this with this new all equals true. That's the only thing that we change. We now have a data frame with the correct dimensions. So notice that in most cases, you're not going to be able to use this names metadata because what this is doing is it's actually just taking the names from the very first data frame. However, if you had multiple names, for example, you can just concatenate and write them out. So for example, you could have something, that looks like this. So by equals, and then a list of variables like this. But to prevent against the .y.x, I've just included all of the names here. If columns have different names, so for example, if something was called object ID in one data frame and ID in the other, you can actually specify your joining variables by doing by.x and by.y. So by.x will refer to the joining variable for the first data set, and by.y will refer to the joining variable of the second data set. Again, I recommend going through and looking at this help file if you have questions, but this is sort of a basic case. If you want to do this in tidyverse, and I really, really like using tidyverse for joins because they have lots of different types of joins. The first types of joins are those that use matches based on keys. So in this first case, you'll notice that I don't have anything called by because the names of metadata 1 and metadata 2 are actually completely identical because I was only messing with rows. So I'm not including that there, but I'll talk about that in a second. What we're doing here is we're grabbing anything that had a row in X or Y. So even if there was a row that appeared in only your X data set or only your Y data set, we're still going to put it in this join data set too. So we can do that and see that it's joining by all of these variables. If we didn't do that, and if we instead said that we wanted to do by object ID or something, then we're going to be in a situation where it's going to put .x, which means this variable was from the first data set. And then we're also going to get these .y's, which means it's from the second data set. So I haven't done that there. But we have in this join data set 2, we have 2815, which is exactly the number we needed. If you use left join, what it's going to do is it's going to say, okay, I'll take this data set and I'll retain any rows that appear in X and Y. So if it's only going to be in the second data frame, it's not going to appear in the final data set. When we do this, we can see that our join data set 2 was only 1,000 instances, and that's because the metadata 1 was only 1,003, and there were only a couple overlapping. You can do the reverse by using right join. So what right join is going to do is it's going to say, okay, I want to take all of the rows that appear in Y, and if it appears in X, great, we'll keep it. But if it just appears in X, don't put it in the final data set. So the left and right is telling you which data set to prioritize. And the reason that you might use this is because say you are merging data frames for, data for different countries or different years, and you're taking external data that's just going to augment your data. All of that external data that doesn't match up to any observations that you have is not going to be super relevant. So that's a situation where you might do that. Okay, and then the final join that's based on keys is this inner join. What inner join is going to do is it's going to create a data set that has only things that appeared in both data sets. So it had to appear in data set X and it had to appear in data set Y. So if we can do that, we can see that there are only 6 observations that appeared in both. So now we've created 3 different types. We've created one where we keep everything from both. We've created joins where we keep things that appear in one and the other, but prioritizing either the left data set or the right data set. And we've created a join where we only keep things that match both. And I've included information about this to the right. But again, say that you have, rather than having all of these joining variables, which only happens if you're basically using the same data sets, and you only have one data set that you want to use match, you'll do something very similar than that you did with merge, and you're going to use this by argument, and then you're going to tell it, okay, for my first data set Y, my grouping variable is object ID, and for my second variable Y, my grouping variable is just ID. So very similar as what we're doing here, except that rather than saying by.x and by.y, we're just concatenating it and using the equal sign. So make sure it's an equal sign and not a comma. We can also use what they call as filtering joins, which are basically just filtering rows from X based on the presence or absence of matches in Y. So for example, a semi-join is going to return all rows from X with a match in Y. So this is different than our left join, because left join is going to keep everything from X and anything from Y that appears in X. This is only going to keep rows from X that have a match in Y. So we run this, we can now see that our dimensions of our joint data set are 6, which makes sense because we had 6 overlapping. But it's going to be much different than our dimensions of our data set where we used left join. Okay. Anti-joins are going to return all rows from X without a match in Y. So again, different because we're saying I'm prioritizing data frame X, but I only want to keep rows where didn't appear in data frame X. So if we do this, you can see that we have now 997, which makes sense because we're doing our 103 and we're subtracting the 6 that appeared in both data sets. And if we flip the order, remember that the first data frame you're putting is X, the second is Y. You can see that your dimensions are slightly different because there were only 6 rows in data frame 2 that appeared in data frame 1, so we're able to keep the majority. So I went through all of this quickly, and there's a lot of information here, but I'm hoping that so long as you understand the sort of basic mechanisms of including your variables and then also kind of telling R how to join the two together, you can kind of use this as a guide to work through it on your own, but definitely will take a little bit of trial and error. But again, just make sure that you're really considering what your grouping variable is. And if you get into a situation where you have all of these random X or Y variables, just remember that the reason that's happening is because they have the same name. And so if they actually refer to different variables, make sure you rename one of the variables so that you can keep them correctly separately. But if they actually referring to the same variables and you want them to be in a single column, then just make sure that you're including multiple grouping variables. Okay, and then just as a final thought that I've already mentioned earlier, but you can, if you're using Teddyverse joins, you can also filter other dplyvar verbs into them. So this might be helpful if you're trying to create another data set and you just want to, specific columns to join or specific observations. So you can go ahead and pipe them in together. All right. So just to recap, we covered a lot of stuff. We talked about removing duplicates, irrelevant columns, irrelevant rows, fixing existing variables, creating new variables, changing the shape of the data, and merging data. All of this is supposed to be more a resource, many lines of code that are, I hope, pretty well commented. But I would encourage all of you to try the test yourself. It's going to help make a lot of these ideas concrete and make sure that everything is clicking. And we have this fun candy data set to do that. So with that, I will leave you to explore.